Assalamualaikum. Okay, so we proceed to our new chapter, which is the gas absorption. So we are going to see the course learning outcome. So our course learning outcome here is explaining what you are going to learn in this chapter. First, you need to describe gas-liquid equilibrium for ideal solutions according to Roth's law, and then you need to differentiate two different types of the tower, which is the packed tower and plate tower. And then you will need to explain the packing materials and flow arrangement that have been used in the packed tower. Then you need to calculate the packed tower diameter and height of an absorption tower. Okay, so these two things we will cover on the packed tower. Okay, the remaining you need to demonstrate the material balance and calculate the number of theoretical stages in multi-stage counter-current operation of a plate absorption tower by a graphical method. So these things is covered in the plate absorption tower. Okay, let us see the lesson plans. So just see here, for the gas absorption we'll cover for 3 weeks. Okay, so this is the column for the gas absorption. So even though you see it looks like the same as others column, but it have different operation conditions. Okay, so the contents of this chapter, there are 5. So first you need to define definitions, application, and notation that is used for the gas absorption. That means you need to understand how the gas operation is operate. And then since we are dealing with the two different phases of gas and liquid, so we need to see the gas liquid equilibrium for ideal solution. That is implies the Roth's law equations. And then you are able to describe the gas absorption, the process, and then the equipment used. So there are many equipments used, but in our syllabus we focus on 2 tower, which is only pack and the plate tower. So for your pack tower, first what is important is your packing material. So you need to describe this packing material and their flow arrangement. And then you need to calculate their pressure drops and flooding. This is the popular theory for the pack tower, where there will be flooding in the pack tower, which is depending on your pressure drop. And then for the calculation, you need to calculate the diameter of the pack tower. We also need to learn about their height. Okay, so for your plate tower, so the theories of the plate tower, you need to understand the theory of the plate tower, and then you need to calculate their stages for your plate tower. Okay, so we proceed with the theory of the gas absorption. So when we are talking about the gas absorption, that means the process of the separation is through the absorption process. So how it is the absorption can occur? So first, by the definition, gas absorption is mass transfer operation in which one or more species, where here we are defined as solute, is removed from gaseous streams by dissolutions in a liquid solvent. So here you can see that we have 2 different phases of liquid and gas. So your gas is the mixtures of your solutes and your other gases, where when we define in the separation, your solute will be your A. Your solute here will be your A. So A and others gas mixture, for example your B, so it will be separated by your solvency. So that's mean here you will have your okay, so you will have your A as your solutes and then your C as your solvents. Okay, A is your solute here. So your solute will be your A, and then your solvent will be your C. Okay, let us see. So since you already know that your gases is in a mixture of A and B, so your gas which have the compositions of A, we call it as the carrier gas. So the insoluble component present in the gas which is not absorbed is called the carrier gas, or here we call it as the B, your B. So your B is your carrier gas. So your A here should be soluble in your C, but your B is insoluble of C. So that's how the separation can be occur for this gas absorption process. So by the theory, the transfer of your A2 is based on the preferential solubilities of your solute A in the liquid solvent C. So that's how the separations can be happen. So your B is not soluble in your C. So for example here we have the H2S in a mixture of natural gas. So your H2S is your solute A and your natural gas is your carrier B. So your removal of H2S from natural gas using suitable solvent such as an aqueous solution of an alkanol amine, which is your solvent C. So the an intimate contact between the gas and the liquid is achieved in the suitable equipment or device. For example, PET column, tray column, spray, tower, and each. So this is the equipment used for the separations of the your separations process. So depending on the applications and so on. So the reverse of the absorption, we call it as the desorption or stripping. Okay, so the determinations and applications of gas absorption. So if you can see, it is the gas absorption is an important equipment in the plant, especially in our gas processing plant. So we see other applications of the gas absorption. For example, first, the removal and recovery of ammonia in fertilizer manufacturing. So we know that the ammonia is important component in the fertilizer. So ammonia in a mixture of gas need to be recovered so that it can be added in your fertilizer. So other than that, we have the SO2 from combustion sources. For example, your car. So we have these poisonous gases. So we need to control the removal of this poisonous gas. So we need to put something in your gas chamber to control these emissions of SO2. And then other than that, we need to control the other gases from rendering plants. So some gases is not good in the plant, so we need to control whether we want to absorb these gases. And then other than that, we want to remove CO2 from air. Sometimes we want to use this CO2 for the ice CO2. Okay, so the important terms in the gas absorption column is there are 4 things. So first is your feed, absorbate, which is actually a gas mixture. So here your feed contains A and B. And then your solvents, your absorbent, which is your C, which the liquid which the feed is contact. So for feed, we have 2 actually. So we have feed for gas mixtures and also feed for solvents. Okay, so for feed here is in a gas mixture. Your solvent feed is we call it is in a liquid form. So the products of our process absorptions, we have the extract products, which is solvent rich products, and your raffinates product, which is your remaining gas mixture. So your solute A will be solute A will be um, will be at high concentration at the extract stream and less concentrations at the raffinate stream. So the solvent, what we call the solvent liquids is, for example, we have several most widely used solvent here. For example, we have water, the hydrocarbons oils, and the aqueous solutions of acids and bases. Okay, that's all for the introductions of the gas absorption, and let proceed with the tutorial. Thank you.